In this tutorial we will discuss basic principle of laser and instrumentation of laser. Let's discuss with basic principle of laser. Lasers are based on principle of stimulated emission that occurs in excited state electron to jump from higher energy level to stable lower energy state. Lasers are based on principle of light amplification. For light amplification to occur, we must have two interrelated the situations as the rate of stimulated emission must be greater than rate of absorption, or in other words the imposed radiation or photon that possess from the sample of atoms must have a greater probability of stimulating emission from an electronically excited atom than that of being absorbed by an atom in its ground state. The population inversion must occur. It means, the number of atoms in upper excited state must be greater than in lower excited state. Such a system is called gain medium. Instrumentation of laser. Lasers are composed of three essential components. They are gain medium that amplifies the light at desired wavelength, pumping source that excites the gain medium, and optical cavity, which consists paired mirrors that direct the light beam back and forth through the gain medium. Let's discuss them in details. Gain medium. The gain medium of the laser can be solid materials, liquid, or gas mixture. The first used solid laser is synthetic ruby rod. A ruby is a crystal of aluminum oxide Al2O3 in which some of the aluminum ions are replaced by impurity chromium ions. The impurity chromium ions are the source of the laser light because electronic levels of Cr+3 ions, the aluminum oxide Al2O3 host crystal, are suitable for achieving a population inversion. The typical chromium doping level is 0.05% by mass. Some of other solid gain mediums are tabulated here. Some gas phase gain mediums used in laser are the mixture of helium and neon gas, mixture of carbon dioxide, helium, and nitrogen gas, mixture of helium and cadmium gas, and the gases nitrogen, argon, potassium, carbon dioxide, etc. The solid and liquid phase gain media can produce both continuous and pulsed outputs at fixed wavelength, but gas phase laser can produce the same at different wavelength. The duration of output varies from nanosecond to femtoseconds. The laser light which is emitted due to population inversion occurring in gain medium must be monochromatic, whose electric field is given as E equal to A cos omega t plus phi, where omega is equal to angular frequency, omega equal to 2 pi nu, A equal to amplitude, and phi equal to phase angle, which ranges from 0 to 2 pi, that means 0 is less than or equal to phi and phi is less than or equal to 2 pi. And the stimulated light wave and incident light wave must be in same phase. This property of laser light is known as coherence. Pumping source. The pumping source is used to excite the gain medium. The mode of excitation by pumping source may be optical or electrical. In optical excitation, high-intensity light source is used to excite the gain medium. Commercially used light sources are continuous lamps and flash lamps. Here, the ruby rod is surrounded helically by high-intensity flash lamp. Because of the discrete energy levels of gain medium, a large fraction of pump light is generally not absorbed by the gain medium. Gas phase laser converts only 0.001% to 0.1% of input energy into the laser light. A few carbon dioxide CO2 lasers and some semiconductor lasers convert 50 to 70% of input energy to laser light. In electrical excitation, intensive electric discharge is used to excite the gain medium. This approach is commonly used in gain lasers. Laser cavity design. Once a population inversion is achieved, a light of specific frequency can be amplified, to generate high-intensity output. This light amplification can be done by placing a resonator consisting a pair of mirrors that direct the light back and forth to the gain medium. Only the light that travels back and forth along the path defined by gain medium can be amplified. If both mirrors are 100% reflecting capacity, this will not generate any output, so instead, one mirror having 100% reflective capacity and other less than 100% reflective capacity are used to get desired result. Thanks for watching.